Okay, the third one. The third one is going to be the most interesting one, which I am afraid I cannot really explain completely right now because it does require something related to inheritance and also dynamic types versus static types. I can mention some intuition about these two notions, but I will promise I will explain to you again later in the course when I speak about inheritance. Let's just do a little bit more intuitive thinking. Okay, so let's read this line together. We are trying to do something on this and something on objects. Notice one thing here. If we are able to reach this line over here, I will make a note. If we're able to reach this line, it's guaranteed. This is not null. And also obj is not null because, for example, if obj was null, we would have returned false already, right? So that's in some way that's the good thing about the multiple return about this logic here. They can argue a little bit better in this way. But anyway, so here we can if that happens, what should we do? We should really just return false. So what does that mean? Okay, let's now take a look. So for this one here, let me explain that clearly over here. So we're doing this dot get class not equal to obj dot get class, right? So what do we really mean? So several things I want to mention. Number one is what does it really mean when we reach this line? Okay, so reaching this line. So let me try to, maybe let me just have more space to write my points over here. Let's say here. Reaching this line means that this, the context objects and obj, the arguments are both not null. That means when we actually try to call this .get class and also obj.get class, remember null pointer exception might occur if the context object is simply just null. But in this case, we know reaching this line is guaranteed. This and also obj cannot be null. For example, if obj was null, it would have just been caught by returning false over here, and we already returned from the method, and we could not even get to this line, right? That's a logical reasoning over here. You want to make sure you understand what I just meant, okay? That means no pointer exception. No pointer exception on, for example, obj dot get class. Okay, I'm really trying to be very thorough for each line. And now that we won't get any null pointer exception, but what does it really mean exactly when we say the objects dot get class over here? What does it really mean? For example, here. So when I say dot get class, now let me use a consistent color here. If I say get class over here, and also we got also get class over here, what does it really mean? Okay, let me just use a slightly different color. Let's say red. Okay, so get class over here simply tells you what? Dynamic type. The context object is. Okay, so here we're talking about a new term for you. So what do I really mean by dynamic type? The easiest way for you to tell what a dynamic type is for an object is by looking at its visualization. For example, when I say, for example, P1 dot equals, let me just write it down. Okay, it's a different one. If I say P1 dot equals P2, and let's assume we have the following visualization for P1 and P2. P1 points to some point V2 objects because we said P1 is assigned to new point V2 by calling the constructor, and similarly for point V2, right? So now if I say P1 dot equals P2, in this case, P1 will be the context objects, and P2 will be objects, the arguments over here. So what does it really mean when I say P1 dot get class and P2 dot get class? it's very easy to see from the visualization. You can think about the title of the box over here. This is really the dynamic type of P1, which you can get from P1.get class. Another way for you to very easily see is, let me just go a little bit further. How would P1 be created in the first place? It would be something like, we'll say point v2, and then let's say P1 is assigned to new, and then point v2, and then we pass on arguments over here. So this part over here is really the dynamic type. Whatever that comes after the new keyword, this is the dynamic type. And indeed, this is how we visualize every object, right? Remember, the way we visualize the object is by seeing which constructor you're calling, and then we're going to create that particular title of the box accordingly. That's something I said maybe you wouldn't pay too much attention to, but that's okay. So now I'm just reiterating the points. Okay, recap. Whenever you say get class on certain objects, you're basically asking about what's its dynamic type, which simply means when you visualize the objects, what will be the title of the box? Namely, when you first created this particular objects, what's the constructor you call after the new keyword? If you call the constructor from point v2, then its dynamic type should be point v2. If you call the constructor from point v1, then that title should be point v1. Okay, so that's about dynamic type. And what's so important about dynamic type? Dynamic type simply tells you whether the structure of the objects will be the same, right? Sometimes maybe having different classes, you might still have the same object structure. But I would say when we really want to, when we do comparison, we want to really compare apple to apple, banana to banana, right? So let's say point v2 is really like an apple. But if you got another dynamic type over here, for example, point v1, in that case, point v2 and point v1, even though both of them got x and y, but you still don't really want to compare them directly because they may have some maybe different attributes you might introduce in the future points. But you really want to compare objects of the same dynamic types only. You don't want to compare any objects of different dynamic types, right? So that means if they are simply not equal to each other, in that case, you're going to return false. Okay, so that's something I want to mention as well. And you might be wondering why we are not using equals method over here. We are just using not equal to. Okay, so that's something I want to also make a quick notes over here. So not equal to over here. So let me just this one I can go a little bit to here. Okay, so this one is doing some object comparison. It is doing some reference comparison. Reference comparison. Okay, just comparing addresses. So the get class over here is going to return some objects of the dynamic type, which is point v2, and then the get class over here is also going to return, if the dynamic type is the same, it's going to just return the same objects of that particular dynamic type. So it's guaranteed to be equal to, but if they are not, then this will not be equal to. So this might go a little bit too much into the detail, but what I can say is this line here is always standard. If you want to make sure the two objects you're comparing, they're really pointing to, pointing to objects of the same type, this is what you have to write, and then you're going to say not equal to. Okay, if you want to see a little bit more details about exactly what's being returned, which might take a little bit too much time, that may not be so necessary, you can reach out to me. Okay, but this is what you got to use. You don't really say dot equals. That's not what you say. Okay. All right, so after this, let's now go on to the next line. Okay.